Hi guys, and welcome to my channel. In this video we will talk about different ways to traverse a binary tree and different algorithms. So we will discuss depth-first search and breadth-first search algorithms, and I will also show you how you can use recursion in order to traverse a tree. And since we'll be using Visual Studio, I want to show you a very useful plugin that many senior developers use. It is called Visual Assist, and it is used in order to boost your productivity and to help you to write better code faster, and also to help you to avoid all those little sneaky errors that are very hard to find and fix. You can use it with C, C++, and C# programming languages, and on the screen you can see some of my favorite features of Visual Assist and how I use it to boost my productivity. Some of the things that it can help you with is it enhances IntelliSense so that it behaves like IntelliSense on steroids. And then it has different code suggestions, spell checking. It is used a lot for refactoring. It helps you with navigating and searching through very large projects, which is usually very hard. It has different code inspection commands and so on. So if you're interested to try it out, you can use the link in the description. And it is a must-have if you plan to make games or work with Unreal Engine. And then if you want to see some of my favorite features of Visual Assist and how I use it, you can check out the video that will be linked here and also in the description. So let's start talking about tree traversal algorithms. Here on the screen, I have a tree, and then in my Visual Studio, I have a code that represents this tree. So I wrote this code in the first part of this video, which will be linked here and also in the description. I'll just show you very quickly what we have written so far. And then if you don't understand something, make sure to watch part 1 and then you can come back to this video. So here I have a code that represents node structure. So here is how one node looks like. It has data, it has left child and right child. And then here is a function used to create a new node. And then this code here represents this tree that I have painted. And before we start talking about traversing trees and different algorithms to do that, I first want you to understand why we need to traverse a tree in the first place. So we are using tree traversal because that is the only way to access the data that is stored inside these nodes and to do something with it, to manipulate it or do something else that we want to do with that data. So there are two types of algorithms that are used to traverse a tree, BFS and DFS, so breadth-first search and depth-first search. And in this video, we are going to focus on depth-first search algorithm. And then if you want me to make a video about breadth-first search, let me know in the comments. The main difference is that breadth-first search algorithm will first search the width of the tree, and depth-first search algorithm will first search the depth of the tree. So here is an example of how breadth-first search algorithm works. So as you can see, breadth-first search algorithm prioritizes width search instead of depth search, which means that it will first visit this node here, and then it will go to the second level. And only after all the nodes on this second level are visited, only then it goes deeper, it goes to third level. And then again, it visits all the nodes on third level, and then it goes to fourth level. Okay, so this is how breadth-first search algorithm works. And then depth-first search algorithm works like this. So as you can see, the order in which these nodes are visited is very different with depth-first search because, as I said, DFS, depth-first search, prioritizes depth over width, which means that it will first visit this entire subtree, so from the top to the leaf to the deepest leaf node, and then it will visit this entire subtree, and then this, and then it will visit this one, and then this, and this will be the last one. So you can clearly see the difference between depth-first search and breadth-first search algorithms. So once again, BFS prioritizes width search and DFS prioritizes depth search. So in this video, we will focus on depth-first search algorithms. There are 3 depth-first search algorithms: Preorder, Inorder, and Postorder. So let's now explain each one of these. And I also want to explain what these data left, right labels mean. So with Preorder algorithm, we first manipulate the data, and then we go to the left child, and then we go to the right child. So let's see how preorder algorithm works on this tree here. So we will start from the root node and we will start this algorithm. So it first says, please manipulate the data. So let's print the data. That's number 1. And then the algorithm says, go to the left child. So I'm going to this left child here and I restart the algorithm. And again, the algorithm says, please first manipulate the data. So I print number 2. And then it says go to the left child. So I'll put L here and I will go to the left child and restart the algorithm once more. So again, I manipulate the data. So I print number 4. And then it says go to the left child, but there is no left child. So I proceed with the algorithm, which says now go to the right child. So I'll put R symbol here and also notice that there is no right child. So the only thing that is remaining to do is to go back to this node here and to continue from where we left. So we manipulated the data, we went to left child, and the algorithm here says that the only thing remaining to do is to go to the right child. So I put R here and we go to the right child, which is this node here. And we start the algorithm once more. So data, which means that I will print number 5 and then visit the left child, which means this child here. And the algorithm starts once more. So data, again, I print number 9 and then I try to visit the left child. There is no left child. I try to visit the right child. There is no right child as well. So I go back and here I try to visit the right child, but there is no right child. So again, I go back to this node here and then I go back to this node here. And here we said data left. So we are remaining with R, which means visit the right child. So I go here and here again, I start the algorithm. So please manipulate the data. So print number 3 and then go to the left child, which is this node here. And again, print the data. So I put number 6 and then I visit the left child. There is no left child. I visit the right child and there is no right child. So I go back to this node here and here data left. So now I do right, which means that I visit this node here and here I also do data, which means that I print number 7, and then I do left, which means that we visit this node here. And again, I need to print the data, which means I need to print number 15, and then I need to visit the left child and the right child. And since there is no left child or right child, I go back and here data left, right, but there is also no right child. So I go back and we have successfully traversed a tree with preorder algorithm. So this is visual representation of preorder algorithm, and this is how you can print all the numbers of this tree with the help of preorder algorithm. Now let's see how this looks like in code. So here is how print tree function looks like with preorder algorithm. So here is the function to print a tree, and I'm going to explain every single line, but first I want you to focus on this part here. So as this preorder algorithm says, we first need to manipulate the data. So we first print the data, and then we visit the left child, and then we visit the right child. So that is the algorithm. And then we also have this condition here, which is called base condition, and it will be used in order to stop the execution of this function. Another thing that I want you to notice is that this function here is a recursive function. Now, a recursive function is a special type of function that invokes itself. So inside the definition of that function, there is an invocation of the same function. So it continues to execute and invoke itself, and then execute and invoke itself, and so on, until a certain condition is met, and that condition is called base case. And that condition will stop the further execution and invoking of that function. Now, if you are not familiar with recursive functions, I recommend you to watch this video. It is beginner friendly and you can learn everything that you need to know about recursive functions in order to understand this code here. And in that video, you also asked me what is real purpose of recursive functions and when are they used in programming. So this is one of the most common uses of recursive functions. They are used in order to traverse trees. So basically what is happening here is this same algorithm. So let's go line by line and explain how this code is executed. So we start from this root node here. That node is passed as a parameter to this function. And then the first line says, please check, is the root equal to null PTR? The answer is no, it is 1. So we proceed, we don't return from this function. And then the second line says, now you need to manipulate the data. So print the data. So we do this part here. Okay, and then we go to the next line. And the next line says, now you need to go to the left child. So we do this part here and we go to the left child. So we invoke the same function, but this time we are passing here number 2. So again, we are entering in the same function. And again, we are asking, is the root node equal to null PTR? And the answer is no. The root node this time is equal to 2. So we proceed from this base case and we go to this line here, which says, now you need to print the data. So we do this part here. And then we proceed with the next line, which says, now you need to visit the left child. So you need to invoke the same function, but for the left child. So we do the left part of the algorithm and we visit this child here, which means that we invoke this same function. And this time we are passing number 4 as root. So again, we are asking, is root equal to null PTR? The answer is no, root is 4. And then we manipulate the data, so the D part. And then we need to print the left child. So we are invoking the same function and we are passing the left child. So this part here, but this time when we are passing parameter to this function, since we don't have a left child, this root node will be equal to null. So when we enter to the function and when we check this condition, is root equal to null PTR? The answer will be yes, because there is no left child. So now we need to return from this function and go back. So we are continuing from here, which means that we are continuing from this node and we are still left with this part. So now we need to visit the right child. Okay, so once more, I'm entering into this function and passing the right child of node 4. And again, there is no right child. So once more, when we check this condition, we will be returned from this function and we will come here and then we will come to the last line, which means that we will go again one step back, and that is to this node here and to this part here. So here is where we left when we were at this node number 2. So we will continue from this R part, which means print tree. And this time you need to pass the right child of this node here. And the right child is number 5. So here we are entering into the function and passing node 5. So when I check, is node 5 equal to null PTR? The answer is no. So we proceed and we print number 5, which means that we have manipulated the data. And then we need to visit the left child. So L part. Okay, and we are visiting this node here since that is the left child. And again, we are entering into this function and passing number 9. We are checking, is 9 equal to null PTR? The answer is no. So we go to this part here. We print the data and then we visit the left child. The left child is null. So when we pass null here, this condition will return us from the function. We will be taken back here and we will proceed with this part, which says, now you need to print the right child. So again, when we enter here with null, because number 9 does not have right child either, we will be again returned by this condition here. And then we will go back and so on until every single element of this tree is printed. So that is how this function here works and prints a tree by using recursion. So now the only thing that is left to do is to check if we are going to get the same output with this function as we did here when we manually applied this preorder algorithm. So I will invoke this function at the end of main. I will say print tree and I will pass the root node. And if I run the program, let's see the output. Okay, so it's 1, 2, 4, and here is 1, 2, 4, and then 5, 9, 3, 5, 9, 3, 6, 7, 15. So as you can see, our function works as expected. So that was an example of preorder algorithm, and now let's see how inorder algorithm works. So inorder algorithm says that we first visit the left child, and then we manipulate the data, and then we visit the right child. So let's apply inorder algorithm to this tree here. So we start at the root node, and the first thing that the algorithm says is visit the left child. So we visit this child here. And again, we restart the algorithm. So again, the algorithm says visit the left child. So we visit this child here. And here again, we visit the left child. And then since there is no left child, we proceed with the algorithm. So the algorithm says now manipulate the data, which means that now we need to print number 4 and then visit the right child. But there is no right child, so we go back to this node here. And here we continue from where we left. So we visited the left child. Now we need to manipulate the data. So we print number 2 and then we visit the right child, which means that we are going to this node here. And here we are starting the algorithm again. So we visit the left child. So we go to this child here and again, left data, which means that we print number 9 and then right. But since there is no right child, we go back and here we continue. So we had left. Now we need to manipulate the data. So we need to print number 5. Okay. And then we need to go to right child. There is no right child, so we go back. And here we also finish the entire algorithm, so we go back again. And here we visited the left child. Now we need to manipulate the data. So now I print number 1, and then I visit the right child. And the right child is this here. So here I do left, okay, which means that I'm visiting this node here. And here as well, I'm doing left and then data, which means print number 6, and then right. There is no right, so I go back, and here I need to print the data. So I print number 3, and then I visit the right child. So I'm going here, and here I will say left. So I'm visiting this node here, and once more left. There is no left child, so I do data, which means that I'm printing number 15. Okay. And then I try to visit the right child. There is no right child. So I go back here. Here I need to print the data. Okay. So I print number 7 and then I try to visit the right child. There is no right child. And with this, we have successfully visited all the nodes of this tree with inorder algorithm. So now the question is how we can translate this inorder algorithm to code and apply it to this function here. Well, it's actually very easy. This here is preorder algorithm. And if you remember, we said that preorder first prints the data and then visits the left child and then visits the right child. And you can see that part here. So data, left, right. On the other hand, inorder algorithm first visits the left child and then data and then right. So the only thing that we need to do is we need to move this line here like this. So first visit the left child and then manipulate the data and then visit the right child. So if I run the program, let's see if we are going to get the same output. Okay, so 429, 429, 516, 516, and then 315, 7, 315, 7. So our code works as expected. So at this point, I would like to encourage you to try and figure out on your own how Postorder algorithm works. So it first visits the left child and then right child, and then it prints the data. So I would recommend that you paint and draw the same way that I did here, and then create your own output, predict the output, and then you can adjust this print tree function so that it does left, right, and then data, so that you can check the output that you get here for Postorder algorithm. Also, I'm going to paste this code in the comment section so that you can use it if you want. So thank you very much for watching. And if you enjoyed this video, please give it a thumbs up, because here we are talking about algorithms, and then you hitting that like button is very important for the YouTube algorithm. You can share it with your friends, with someone who needs to learn about data structures and algorithms, because I know that many students are struggling with these topics. So you can be that person who sends them a video that might help them, because I really try to explain these topics in a very simple and understandable way. So I hope that these videos are helping you guys. So thank you very much for watching, and I will see you in some other video. Bye!